Good afternoon, everyone. For those who don't know me, I'm JonathanCain, the operations manager of Weed Free on Track. The good news, it's almost time for an alcoholic drink. So I will rattle through. So I figured a lot of people would be talking about the sort of modern current state of weed control. So I thought I'd take a different approach and look at where we've come from in my presentation. So to give you a bit of background, Weed Free, our company, has been operating on Europe's railway tracks for over 20 years. We've worked in many countries: Belgium, Denmark, France, Sweden, Norway, the UK, to name them. Each country has its own unique set of challenges. They all handle, although it's a European sort of state, every country has their own regulations and ways they handle things differently, which creates its own challenges. So from the early 2000s, the chemical landscape has changed dramatically. Environmental impacts and health and safety regulations have increased vastly, which has had an impact on the way we carry out the work. So during this presentation, we're just going to take a look at how this has evolved. So this is our original conventional spray train. I think that's Scotland, where we were working at the time. So it's a very old school approach to weed control. It involved storm washing, which is essentially similar to what the Americans are doing now, where you just obliterate the network. Yeah, and it's very functional, but inefficient with regards to the environment. So you can see these are our guys operating this train. Health and safety is a bit lacking. It involved the guy sticking his head out the window and looking for weeds visually, which you would never get away with now. In those days, similar to what Ryan was saying, the stronger chemicals, the better, the more effective. We wanted to achieve a total kill of the network. Environmental protection was secondary. It was predominantly for a health and safety perspective, but also to make the network aesthetically pleasing. Just an example, we used to hand spray the stations in the UK, and we've been called back a number of times to spray a station to make it look nice because someone important was passing through the station, which you would never get in the modern day. So some of you may recognize the guy in the top right. It looks like he's about to go play tennis, I think. Yeah, very different to modern day PPE. And then in the bottom right, well, yeah, he's got wellies on. I think that's all we can say. But this is an example of where we were at in the 1980s. So one of the first evolutions of railway weed spraying from a train was a contained cab. So rather than having to stick your head out the window and look for weeds, you could sit in a cab, in the safety of a cab. You would have a central operating control. It would protect the staff on board. Generally, it was a better operation all round. It reduced the number of staff that were needed to carry out the operation. You could have one or two operators rather than a group of operators. This is the vehicles that we used in the UK. Amazingly enough, they still use these machines to carry out weed control in the UK. So yeah, it gives you an example of where they're at. So we sort of Galgal evolved this concept further with our spraying trains. So rather than requiring an operator to be in a locomotive or the front end or rear end of a cab, a control room, a dedicated control room, was moved to the center of a spray carriage. Generally, they put the cab above the spray frame, so it gives the operator sort of positional sense in relation to the train. You'd have a multi-camera setup. So when technology was at a level where it could be at, it was easy to equip cameras to the outside of the train, and one person could monitor all aspects of the operation. In more recent times, the cab was positively displaced, so it would protect the operators from chemical fumes, and would just offer a good level of protection. And finally, if the cab is in the middle of the spray vehicle, then it allows it to work easily bi-directionally. So the next sort of evolution we reached, where technology was at a stage, we evolved into weed mapping. So obviously, just spraying the whole of the network isn't a very effective or environmental method of weed control. So G&G were one of the first adopters to adapt this onto the railway networks. Like Ryan said previously, a lot of these technologies have been around in agriculture, which is a multi-billion-dollar industry. But spraying a field and in a controlled environment is a lot easier than a railway network where there's thousands of different variables you have to deal with. So Galgal adapted a camera-based solution. You would put cameras on the front and rear of the train, and they would scan the network, as you can see in the bottom right image. And when a weed passed through that sector, it would tell the spraying unit to spray that section. The system utilizes cameras to recognize the green weeds, and then it applies herbicides to those locations only. It's paired with a sophisticated spray setup to allow a much more accurate level of treatment than stone washing. On our trains, the track beds divided into 9 sections, and they could all be treated individually or simultaneously. We've saved over 70% in herbicide reductions using this method. It's sort of a tried and tested method. One of the other things is if you're using operators to manually spray, they have a limit to the speed at which they can react. So either they do a bad job if you go above the speed, a workable speed, or they can't do it. A computer doesn't have those restrictions, or it doesn't have as low restrictions. They can work at a much higher speed. So, for example, in Belgium, we spray at 60 kilometers an hour, which allows us to run within the constraints of the railway network without impacting traffic. So Harold touched upon this, but it's interesting. So in the olden days, sensitive areas were far and few between. And because they were so, they would literally be managed by a person with a piece of paper and a list of kilometer posts on them. And when the train got to that kilometer post, the guy would switch off, and you'd hope that all the kilometer posts are present on the network, or things could go wrong. As GPS systems became more sophisticated in more recent times, it allowed us to manage them more safely and effectively, particularly when environmental restrictions became much more stringent. So as we discussed already, there's more and more sensitive areas across a network to the point at which management is impossible without using automated means. So this is a picture from Denmark in 2013. So in total, there's 11 sensitive areas here. We were given this piece of paper. It shows the kilometers, and we just switch off when we get to that point. Plain and simple. Fast forward to 2023, every pink area on that map is a sensitive area. I don't know how easily you can see them here, but there's thousands. The same in Sweden, there's over 5,000. It would just be impossible to manage them any other way than automatically with the train. So essentially, we upload a GIS data set onto the train. When the train reaches a GPS coordinate, the thick green line is a sensitive area on the old system on the left in the box. So when that cross reaches that, it tells the operator a warning, and the operator would switch off the spraying. And then when they pass that section, they would switch back on. So on the right-hand map, you can just see a general overview of where the sensitive areas are, the green blocks. This is Sweden, so as you can see, there's a lot. This video, it might beep loudly. It's a bit of a rudimentary video, but you can see it in operation. So you're just coming in within 100 meters of a sensitive area. So the system beeps and warns you and flashes red. And then the operator, when they get to about here, would switch off the spraying for the duration of the sensitive area. Now, it looks, like I say, it looks really rudimentary now compared to our modern system, but it was a really effective way of managing the sensitive areas compared to what had gone previously. So what these upgrades in technology also allowed was much more sophisticated data reporting. So in the olden days, you would hand over a piece of paper with the day spraying, how much chemical you used, the sections of track that you passed. But with the use of GPS and mapping technology, we could create much more sophisticated data reports. with the technology at the time of where you're seeing the weed map, we could provide per meter data. Again, this was further enhanced when we could create GIS maps for the clients to visualize where had been sprayed. So on our trains, we adopted technologies such as GPS, differential GPS, RTK corrections, and an inertial measuring unit, which was very sophisticated at the time to provide precision level accuracy across all the countries we worked in. So what that would allow is we could get sort of true to scale representations of infestation across the railway network. The train would record all aspects of the spraying, and then we could report that back to our clients by the meter, by the 100 meter, however they wanted. We could create bespoke reports. On the right, you can see one of the traditional weed maps. This was an original way of visualizing the infestation across the network before things became more sophisticated. But it was functional. You could put in the coordinates on the right and you could see where on the network and how dense the weeds were. And it allowed us to carry out a residual treatment the following year based on where the weeds were the previous year. So with the improvements in technology, it allowed us to create semi-sophisticated GIS maps so we could start proving our accountability to the environment agencies. As you can see, as we zoom in, I think this is in Sweden, but the green blocks again, sensitive areas. We can hand this over to the environment agency or a relevant body who is interested, and we can demonstrate exactly where to the meter the nozzles were switched on. We can show we've respected sensitive areas. So rather than just providing a piece of paper signing that we've respected them, we can actually give them the hard evidence. So at this stage, the train was almost a complete solution with what technology was on board. We were very happy with the level of sophisticated equipment on board, but it wasn't truly global because it was limited to the railway gauge that we were using, which was European gauge. Obviously, in Europe and outside of Europe, there are other railway gauges. So Galgal and ourselves look to adapt this technology, shrink it down and put it in a container. So as you heard previously, the SNCF are now using 5 of these units in container format. So it's essentially the same technology, but it's condensed into a workable format. Obviously, the benefits are that it's gauge independent, easily transportable. You can rapidly deploy it and store it. It just makes it a much more flexible unit. So you have both options. So moving forward now, we're sort of on the present day of where we're at with technology. And we've reached a stage where technology is sophisticated enough that we can carry out a fully automated treatment. The problem with operators is that they are not infallible. They lose attention, they get tired, all these things that can affect the operation. Computers don't do that. They continue as they can do. So the technology is at a level now where we can program it to respect sensitive areas with 100% success rate. So we program in complex GIS polygons and the computer will respect them. And then the operator can focus on other things like hazards, workers on the track, people, so they can work in unison to create the best solution possible. Whereas before, if the train reached a sensitive area, it would just switch off the whole operation. Now we can teach it to work laterally. So if a polygon only requires switching off the outer nozzle, it knows to do that, or all the nozzles you can see in the next video that I'll show after this slide. So here you'll see it on the bottom left. You can see the nozzles would switch on and off according to where the sensitive area is. So the computer knows, it's sophisticated enough to know the shape of the polygon and switch on and off the nozzles automatically or altogether if needed. So now we're at a stage, I'm sure you've all heard plenty of times, artificial intelligence is on the rise. What it is doing, it's opening up the field to more intelligent treatment methods. One that we're looking and investing heavily into is species recognition. Again, this has been in agriculture for a period of time now, but the railway environment is so much more complex that it's a much different beast. So what we're doing is we've attached cameras. This is one of the older systems. It's evolved since then, but we've got 5 cameras on each of our trains. They will be taking hundreds of thousands of pictures of the network as they go along. You can see the sort of image that it will be providing in the bottom right. We will then go through a machine learning process where we will teach a computer species of weeds. We'll target specific weeds that we want to look at, for instance, equisetum or Japanese knotweed, for example. And we will manually teach the computer until the AI can recognize on its own those species. And then when the train goes out in the future, it will be able to recognize them on its own. And then we'll be able to create invasive species weed maps. We'll be able to use chemicals targeting specific weeds, for example. There's lots of possibilities. It's a real big development that we're excited to sort of push forward. And at the minute, we're sort of focusing on the 8 meters, but we know that certain invasive species are in the outer sections of track. So that's sort of the next evolution of that, where we'll be trying to, for example, map giant hogweed in the shoulders of the track, and then we can give clients weed maps where they can go and physically target those areas with manpower. So it's an exciting development. One of the other developments, obviously, the world now is permanently connected to the internet, and we realize this. Our trains are also now permanently connected, so they can be tracked live time. All data is on a constant upload stream to the internet, to the point where within 30 minutes you can track a lifetime treatment. This is one such example of the level of reporting where we're at. This is in Denmark. So I showed you the rudimentary weed map from days past. Now we can actually map that out on the network. We could give someone the coordinates and they could go out to that section of track and they would see this representation within a period of an hour. So it's really useful, such technology. So that, yeah. So yeah, sort of we're touching upon the utilization of this data now. That's where we're at to sort of round things off. So the level of detail is such that data can be used to target problematic lines. What we've seen in recent times is our clients are starting to use this data to plan treatments effectively and environmentally, so that they are not treating lines unnecessarily. So they will look at the infestation data, they'll look at the lines which have the highest levels of infestation, and they'll put a threshold where if it's below a certain amount of infestation, then they won't treat it that year. They'll skip it for a year. So it's sort of using the data intelligently. I think it's sort of, Harold touched upon it, it's now an accepted practice that in Europe there will be weeds on the network, and it's sort of working intelligently to find the level that is acceptable and is not unsafe, and working within the sort of constraints. And that's where we can use this data effectively. And lastly, yeah, railway operators are able to target sensitive areas. So we know in Sweden, again, what Harold was saying, if 80% of a section of track is sensitive area, then is there any point in spraying the 20%? The argument could be we can map the whole of that line, we can see what level of infestation is, and then they can send a mechanical team in to treat the sensitive area without using invasive methods of treatment. So there's lots of methods. We're seeing our clients start to track the cleanliness of ballast. Ballast cleaning is very expensive. It's very time consuming and impacts the network. So we're seeing our clients use data to try and find the optimum balance of when to carry out ballast cleaning. So there's loads of, it's sort of the data moves out of the realms of weed control and into other fields that sort of are closely linked. So it's interesting over the years to see how this data and moving forwards will be used in the future. And that's about it. Thank you.